All right, this is how to do number 20 on homework 1.3. This is otherwise known as the mean value theorem question, which is pretty spooky, pretty scary. But let's break it down so we can understand this a little better. So first off, we've got some function. We have a theorem from calculus that says if I go across the interval from -1 to 2, so these are x values that are in between -1 and 2, it says there's going to be some number in between -1 and 2 where the average rate of change across -1 to 2 is equal to the derivative. Don't necessarily worry about what the derivative is or what it means too much. Point is, it's given by this function. So what we're saying is, at some point in here, there's going to be some spot where the average rate of change is going to equal whatever this spits out when you plug in that x value. So my goal is to find those specific x values where when I plug x into this guy, it's going to spit out the average rate of change. So the first thing that we need to do is figure out what the heck the average rate of change even is for this. And the way that we do that is we find the endpoints where this function is. So I find out what my y value is when I plug in -1. I find out what my y value is when I plug in -2. And I get some points that are on the graph of f. So if I do that, it turns out that I get 1 or -1 comma 10. I'm very carefully plugging in -1. If you're wondering why this is already done, I had done this live and did not get a good recording, so I'm redoing it. But I carefully plug in -1 and simplify to get 10. Next up, I carefully plug in 2 and I end up getting 28. So let's actually take a look at how this presents on the graph. Let's go to Desmos real quick. I'm going to copy the same function that I had from before. So I'm going to say f of x is equal x cubed plus 4x squared minus x plus 6. So this is what this f looks like. I'm going to go ahead and make that bold and turn those off. So it kind of looks like this little noodle shape. All right, and we just found out that I'm interested in only the interval from -1 to 2. So this is really the only part that I'm interested in. My whole function was doing some other crazy stuff, but I only really care about this part. So I'm going to get rid of everything else and only focus on this part. Okay, so now you'll notice that if I plug in -1, I'm supposed to get out 10, and boom, that's the point right there. So we'll keep that labeled. The other one that I had was 2 comma 28. And sure enough, that's this other guy over here. So the average rate of change is going to be the slope of a line that connects these two dots. That's the average rate of change over this interval. The slope of the line that connects these two dots. So the next thing I need to do is actually calculate what that slope is. So I use my slope formula, which is change in y over change in x, otherwise known as rise over run. And I'm going to carefully calculate this using the 2 points that I had. So I subtract my 2 y values, and that gives me -18. I subtract my 2 x values, that gives me -3. So it looks like my average rate of change is going to be 6 when I simplify it down. And if we test this out real quick, I'm going to say, it's actually y minus 10 equals 6x minus. Yep, sure enough, I just drew the line that we were talking about. Here's the line that connects 2 points, and you can see the slope of 6 works to connect both points. So this is proof that I did it correctly. So now what I have to do is I have to figure out what x values for this new function, the derivative function over here. I need to find an x value, so that way when I plug in the x value, this needs to spit out 6. It spits out the average rate of change, which we now know is supposed to be 6. Okay, so I need to solve for x, so that way this is my derivative over here. My derivative function equals 6. I basically took the derivative and I set it equal to 6, and now I want to solve this for x. However, easier said than done. So all I did was I made it equal to 0 by moving the 6 over to the other side. And at this point, there are quite a few ways to solve this. However, the way that I chose was using the quadratic formula. So the quadratic formula says that when you have a function that looks like this, which is what we have, I have something x squared plus something x plus a number equal to 0, then your answers always look like this. So I'm going to go ahead and highlight this blue. Your x value answers are always going to take this form. So what I did was I very carefully substituted out everywhere I saw b in this formula, it got replaced by 8. Everywhere I saw an a, it got replaced by 3. And everywhere I saw a c, it got replaced by -7. So when I did that, these ought to be my answers. I simplified pretty carefully, making sure to do these operations correctly, because if you mess those up, that tends to be where the errors happen. And then I get this. So at this point, I decided to split it up into 2 separate answers, because that's what this plus and minus symbol means. It means one answer uses the plus, and the other answer uses the minus. So at this point, it splits into 2 different answers. So this is technically correct, and so is this. However, there's a chance Pearson might mark this wrong, because it's technically not simplified the whole way. So what I did next is I simplified this square root into 2 times square root 37. Those two things are the same. Very complicated. I did a small shortcut for how to do this. The way that you can easily figure out how to simplify a square root is to do a factorization, or a prime number factorization more specifically, of the number underneath the root. So I said to myself, okay, well, 148 is even, so I can definitely divide by 2. So this splits up into 2 and 74. 74 is even, so it can definitely split up into 2 times something else. And turns out it's 2 times 37, and those are prime numbers. So my prime number tree is 2 times 2 times 37. If you see any pairs of numbers, then one copy of the number that you make a pair for goes into the front of the square root. Everything that doesn't get a pair stays underneath the square root. So this is how I came up with 2 times the square root of 37. Okay, so my square root went from this to this on both pieces, this one to this one. I simplified that. So now what I notice is that this is even, and this is even. So all of those numbers can get divided by 2, and this will still be equivalent. It's the same idea behind reducing. Oh, if I have 4 divided by 6, this is the same as 2/3, right? You divide by 2 and divide by 2 on the top and bottom. Same idea, I just did it to all of the pieces. And that's where 4, the 2 divided by 2 turns into 1, but I don't need to write a 1, so I just didn't. And 6 divided by 2 is 3. So that's where my simplification came from. However, there's a catch. Only one of these answers is quote unquote like the real answer. The reason is I'm talking about the interval from -1 to +2. So one of these two numbers is not actually in this interval. So let's check out this guy real quick. Actually, better yet, let's start with this one. So if I start with my negative answer over here, or my answer 2, I'm going to double check to see what my answer 2 is. So here it is. If I type this into Google Calculator and simplify this, this is actually -3.36. This is too small. So I'm going to say approx -3.36. I don't need that many digits. This guy over here, again, I'm going to copy paste to double check how much this equals. This is 0.69. So this is going to be 0.69, roughly. So my conclusion is this one is in this interval. It belongs in between -1 and 2. However, not this guy. This one does not belong to this interval. So my only true answer is this. This guy right here is my answer, not this one. Okay, so this is approximately the value where the derivative matches the average rate of change.